Hey, this is G down on the Realize Live floor again, and I'm here with Ben from Siemens, who is one of the experts in digital transformation applied to industrial automation. Could you just introduce yourself and kind of what your role is and what you've been talking about with folks down on the floor here?
I'm Ben Green with Siemens Digital Industries. I focus on our automation platform, specifically around our discrete automation, helping customers figure out how they're going to get from what they do today with our traditional hardware, but also how they now bring in our software portfolio to do this digital transformation idea that we're bringing to market.
One of the key things we were just talking about was the digital twin concept and like what is actually involved in doing that. What are some of the aspects that if people are interested in using digital twin, like what does that actually mean and how are folks applying those concepts?
It's a broad topic for sure, and I think it's always it's in the eye of the beholder of what a digital twin is. We typically look at three types of digital twins. There's a digital twin of a product, the digital twin of production, and a digital twin of performance. In the automation space, we're typically looking at that digital twin of production and how we're actually going to put a product together and we're going to assemble a product in a machine and then how that machine is going to perform over the long term inside of a plant.
I mean, I know it's like a broadly interested topic, I think. Who are like the key customers who really are seeing the value of starting to invest in digital twins if they haven't yet?
I think the OEM machine builders and the end users, absolutely, depending on what their different goals are, especially those in those industries where machinery is very expensive, it's very big, physically very big, it'd be very expensive to make a mistake. And so they want to try to get all of that out ahead of time in the virtual world before they invest thousands, hundreds of thousands, even millions of dollars in a new machine design. They want to validate that as much as they can ahead of time.
When I think of it as a control systems integrator of a digital twin, I always go directly to virtual commissioning, right? Like I'm writing code. If we can prove that it works on the machine before we're physically on the machine, we're reducing the commissioning time potentially and mistakes. What are some of the other use cases that are not in that bucket?
You brought up a good case, and I agree. That's always kind of the first thing everybody kind of zeroes in on is the virtual commissioning, and that's absolutely a great point. But I think there's other things that you could do. And so there's things like machine validation that have to happen. So not just virtually commissioning the machine to make sure it behaves like we think it should, but doing things like potentially safety validation. So validating machine with our software products and validating the human factors of what happens if someone puts a hand through a light curtain. How does the machine respond with that digital twin, with the physics? Does it stop in time to protect that person that enters that restricted area of the machine? It could be things like digital validation, potentially maybe in pharmaceutical. Maybe you get a lot of the FDA type certifications in place virtually, or at least make sure that it's going to pass the FDA certification before you actually go deploy a change on a machine. So customers that are in that space that have to worry about validated machinery, I think a lot of the validation steps can happen virtually. Potentially. Siemens' own experience, we have a brand new drives product called the Dynamics G220. It was fully certified by UL virtually, without actually having to go and blow up a bunch of drives in that space. We were able to actually show UL that we did all the testing and all the thermal compliance and all that virtually without having to actually do destructive testing with the product. So there's a ton of use cases that are out there for it.
I'm actually curious about the effort to get to realism of the physics, right? I actually did my master's in simulation and optimization, and getting the physical model, right? The amount of detail you put in can be a big effort versus benefit, right?
Absolutely.
And where do you stop? How are customers making that decision and in that investment?
Yeah, I think ultimately it depends on the value of their process and where they can define that value. So it's a highly mechanical machine, then obviously the physics behind it, where we're moving a big mass, or maybe a robot picking up a large mass of some sort. How is you want to know how that robot's going to behave in the real world. 1,000-kilogram, 1,000-pound mass hanging off of it. For our chemical customers in the process industries, they want to be able to simulate down to a molecular level of how these products actually combine and how they react in a chemical reaction. We can actually simulate that piece of it. Certainly some of these products can be very expensive, they can be very volatile, and so they want to be able, so there's a high value in being able to simulate that before you have to go and ruin or test and validate that ahead of time. So I think it ultimately depends on the value of the product that you're making, is what you're going to do with it, but certainly there's a big case to be made for getting the high fidelity model as you can.
Slightly different topic, but I know you were mentioning that I think a case that we didn't talk about yet is the ability to market a product with a digital twin, right?
Yeah.
Actually closing a sale because you have building something completely custom.
Right. Well, as a customer-facing sales guy for so long, this one actually makes me probably the most excited. I see customers and more customers that they're, and you kind of brought it up, is, how much time is it worth? What's the value of it? How much money are you going to spend? Is we think about the virtual commissioning and building the model, but I think there's a whole missed opportunity there with the marketing piece. Is how much money does it take for a machinery OEM to go to these major trade shows to bring a machine in, wire it up to the 480 volts, wire in, water or air or whatever they need to it. It could be thousands and thousands and thousands of dollars. But how about a virtual twin running in their booth at a trade show with all the full fidelity model, showing exactly how it operates with the physics, with maybe a physical HMI so their customers can operate the machine just like they would if there was a full machine there. And we've even seen customers be able to take those models and actually on the fly run new products, like a customer specific product. So their customers are coming to them on the trade floor, say, hey, what would it look like if I ran my product through your machine? It may take an hour or two, but maybe they CAD up a mock-up of their product. They can actually then run that through that virtual model and the virtual machine on the trade floor and actually show their customers what they're doing. So now you're not only taking the cost of and the time and the effort to build the model, right? But you now have this marketing piece and you're selling more machines, especially for the machine builders. What does that mean to them? If they could sell 3, 4, 5 more machines per year with a digital twin and you're using the same tools that you're investing in on the engineering side, it's a huge payback. It could be a huge economic benefit for them.
Yeah, for sure.
That they didn't even know existed.
Yeah, now you can actually have the AR headset or something they can actually experience in real time.
Yeah, absolutely. I mean, VR is a part of it now, right? We're seeing that more and more. It's augmented reality or be able to step through a plant simulation where you can walk through. So the sky's kind of the limit of what you can do with it. And I think even end users, we were talking with an end user earlier, I think it's kind of neat even for their marketing, for their products, to show how high tech and the simulation that goes into their products and the care that they use to craft their products, they're selling to their end users. I think there's a marketing play even for the end user community in that to show off their high tech manufacturing skill set.
Awesome. Well, I think that this is definitely where the industry is going. Even 5 years ago, was we had earlier adopters, but I think it's going to be the norm very soon.
I think it will be. And I think, the other thing too, we were talking maybe earlier, is that the operator training piece of it is we've got the simulation piece for operator training. So people are trying to upskill their workforce and how they train operators to use their equipment. They don't have to train them on big, expensive equipment that can be hard to get time on. It can be dangerous to train someone new that doesn't know how to operate it. And run material through it, right? And so then they can do all that virtually and they can see what happens when a jam happens or an overpressure event happens or something. They're perfectly safe. They're in the environment. I always tell people it's like you want your airline pilot to have practiced what an engine out procedure is in the simulator. You don't want them practicing on the $1 billion Boeing jet, right? So you want to make sure that they've got that in place.
Awesome. Well, thanks for talking to me. It's definitely an exciting topic.
Yeah.
And glad to hear more.
Thanks for having me. I appreciate it. Thank you.